Alright, what's up guys? In this video we're going to pick up with some differential equations. We're going to talk about exact ordinary differential equations again. So as to solve the given exact ODE. So we're given 6x squared y squared dx plus 4x cubed y dy is equal to 0. So an exact ODE must take the following form: m of x comma y dx plus n of x comma y dy is equal to 0. So it must take that form. The first step in solving an exact equation is to determine whether or not it's exact or not. But before we do that, let's identify m of x comma y, which would be 6x squared y squared, and then n of x comma y, which will be 4x cubed y. So let's run through the test for exactness right quick just to verify that it is an exact equation. Doesn't hurt to run through this test quickly. As long as you're good with taking partial derivatives, it shouldn't be too hard or take too long for you to just briefly run through the test. So the test for exactness tells me that for the equation to be exact, the partial of m with respect to y needs to be equal to the partial of n with respect to x. So let's go ahead and do it. So let's take the partial of m with respect to y. So the partial of m with respect to y, that's going to be 12x squared y. Okay. And then we need the partial of n with respect to x. And the partial of n with respect to x is going to be the same thing. It's going to be 12x squared y. So as you can see here, the partial of m with respect to y is equal to the partial of n with respect to x. So this equation is exact. It doesn't hurt to run through the test. Now, the solution form for an exact ODE looks a little funny, but it is the solution form. The solution form is f of x comma y is equal to c. So there are two ways that you can go about finding f of x comma y. Okay, you can integrate n of x comma y with respect to y, or m of x comma y with respect to x. It's entirely up to you which one you choose, although one may be easier than the other. So to find f of x comma y in our case, again, neither of these is harder to integrate than the other, but I'm going to integrate n of x comma y with respect to y. So if we do that, that'll be f of x comma y is equal to the integral of 4x cubed y with respect to y. So what we'll get when we do that, it's going to be 2x cubed y plus g of x, because keep in mind, since we integrated with respect to y, we're now going to have to partial differentiate f of x comma y with respect to x. Okay, so we can say that f of x comma y is going to be 2x cubed y plus g of x. All right, so we now need the partial of f with respect to x. That's what we need to compute next, which means that we need the partial with respect to x of 2x cubed y plus g of x. So if we take the partial there, we'll get 6x squared y squared plus g prime of x. Okay. All right, so we've done that. All right, the next step, remember, is to set the partial of f with respect to x equal to m of x comma y in this case, since we integrated n of x comma y with respect to y. So let's do that. So if we do that, that'll be 6x squared y squared plus g prime of x. We'll set that equal to m of x comma y, which was 6x squared y squared. Now we need to solve for g of x, so if we subtract 6x squared y squared from both sides, we'll get g prime of x is equal to 0. We need to solve for g of x, so we just integrate both sides, and obviously we can clearly see what we're going to get. Clearly, g of x is just going to be 0. Okay. Technically 0 plus c, if you want to be technical with it, but so we now have a g of x, so what we'll have is f of x comma y, it's going to be equal to 2x cubed, y cubed is equal to c, which would be your answer. So your final answer for this exact equation so your final answer is going to be f of x comma y is equal to 2x cubed, y cubed is equal to c. That's your solution to the exact ordinary differential equation. So let me circle that for you. So let me know if you have any questions about how I arrived at my answer. I'll be more than happy to go over it with you. All right, that's going to be it, guys. I'll see you guys next time. Y'all take care.